This is Pre-Calculus Section 1.4 Notes, Day 1. Today we are going to be reviewing rational expressions. A rational expression is a fractional expression where both the numerator, I'm going to abbreviate that n, and denominator are polynomials. So essentially, rational expressions are fractions, but we can have a polynomial in our numerator and a polynomial in our denominator. So here are some examples of some rational expressions. We could have 2x over x minus 1, or we could have x over x squared plus 1, or x cubed minus x over x squared minus 5x plus 6. Just a few examples of some rational expressions. Whenever we talk about rational expressions, we always need to talk about domain. Okay, so the domain consists of all values that define, or we could also say satisfy, the expression. Restrictions on the domain exist where there is a variable in the denominator and or there is an even root in the expression, okay? And I have these domain restrictions on my classroom wall on the above the whiteboard on the green poster too. So you can always look there if you can't remember what to look for when you're considering domain. So let's take a look at a few examples here. It says, find the domain of the expression, express your answer in two ways. Okay, so we'll get to that when we talk about what the domain is as far as how we can express it in two ways. All right, number one, we've got 3x squared minus 6x plus 1. This example does not have a variable in the denominator, and it does not contain a root. Okay, because remember, our denominator here is a 1. If you don't see it, it's a 1. So if we don't have a variable in the denominator, we don't have to worry about creating 0 downstairs. If we don't have any even roots, we don't have to worry about keeping it positive under an even root. So our domain is going to be all reals. So we can say x equals all reals. That's one way we could write it. But let's also write it in interval notation. So all reals would be all numbers from negative infinity to positive infinity. In interval notation, negative infinity to positive infinity looks like that. Now remember, when we work with infinities, we always use round brackets with interval notation. Number two, this time we have a numerator and a denominator. And if you look at our denominator, we have a quadratic trinomial that could be factored. That's going to be an easy factor on the bottom. So let's go ahead and factor that because that will help us figure out our domain. We're looking for a pair of numbers that multiplies to make negative 15 and adds to make negative 2. So that's going to be negative 5 and a positive 3. So m plus 3, m minus 5 for my denominator. Okay, so now we can easily see that there are two values that could make my denominator 0. If m were negative 3, that would create a 0, or if m were positive 5, that would create a 0. So for our domain, the easiest way that I think we could write it is we could just say that m cannot be or cannot equal negative 3 or 5. Okay. Now we can write this in interval notation as well, but if there are two numbers that it can't be, but it can be anything other than those two numbers, that means that we're actually going to have to write a union of three intervals because our m values could be anything from negative infinity up to negative 3, but round bracket on negative 3 because it can't be negative 3, right? It can be anything between negative 3 and positive 5. Again, round brackets on both. And then it can be anything from positive 5 to infinity, round brackets on both. Example number 3, now you see we have a root. And what we know is that in order to keep things real, since we have an even root, this is a square root, so remember there's a little invisible 2 right there, that means that we have to keep our expression underneath our radical positive. So that tells us that 3x plus 5 has to be 0 or bigger. So we're going to say 3x plus 5 has to be greater than or equal to 0. So we can just do a little algebra here. Solve for x. So that gives us our domain. That tells us that all of our x values, if we want to keep this expression real, all of our x values have to be greater than or equal to negative 5/3. Now, if we were going to write that in interval notation, that means that x can be negative 5/3 or bigger. So negative 5/3, comma, infinity. We know we're going to have a round bracket on the infinity. X can be negative 5/3. So if we want to include negative 5/3, we need to make sure we put a square bracket around negative 5/3. Example number 4. In our numerator, we have p plus 7. That's not going to be an issue for our domain. But in the denominator, we do have an expression that we need to keep positive, right? So we could do a little bit of factoring here. Just a simple GCF underneath that radical. We could take out an 8. And then we're going to have that factor of p minus 2, right? So we know that tells us that our p minus 2 has to be, we have to keep that 8 times p minus 2 greater than or equal to 0. Well, we could divide by 8. That has no effect on it. So p minus 2 has to be greater than or equal to 0. And if we add 2, we determine that p has to be greater than or equal to positive 2. Now, we do have an issue on this one. This expression is in the denominator. So since it's in the denominator, we can't equal 0. If p were 2, that would make the expression under the radical 0. And if it were in the numerator, that would be fine. But since it's in the denominator, this time it's not fine. So we actually can't say p's greater than or equal to 2. We have to say only greater than 2 because we can't have 0 in the denominator. All right, so my domain here is going to be p is greater than 2. In interval notation, we can't include 2, so round bracket, 2 comma infinity with a round bracket. Okay, next we are asked to simplify a few expressions. And a rule to remember here, let's talk a little bit about reducing. If you had x over 2x, that can be reduced. You could cross out the x upstairs, cross out the x downstairs, and you'd be left with 1/2. But if you had x squared plus 1 over x squared plus 4, I want to remind you that those are families, right? I always put parentheses around those, and I always talk about those as families. Whenever there's a plus and a minus, if your family is not exactly the same, then you cannot cross anything out, okay? So we would not be able to cancel anything on that second expression. Now, whenever we are trying to simplify rational expressions, always, always, always factor first, okay? This is the law of the land with rational expression simplifying. Factor first. All right, so let's take a look at example number 1. We've got 4 minus x squared on the top. Hopefully you recognize that 4 is a perfect square and x squared is a perfect square, and you've got a minus sign between. So this is a DOS. It is kind of backwards. Don't let that bother you. That's going to factor into 2 plus x and 2 minus x. Then on the bottom, we have an easy trinomial. A is 1, so we're looking for two numbers that multiply to make negative 12 and add to make negative 4. So we're going to do, oh, excuse me, I want to change that. I want to change that to a plus, okay? two numbers that multiply to make negative 12 and add to make a positive 4. So I'm going to look at x plus 6 times x minus 2. Okay. So now when you look at this, you're looking for families that are the same. And hopefully you're saying right now, well, there are no families that are exactly the same, because that's the truth. However, there is something here that we can do. And that's what this little box here is telling us about. We will use the -1 technique. So I want to call your attention to the 2 minus x in the numerator and the x minus 2 in the denominator. These are not the same. However, they are something called opposite factors. Okay, so when we have opposite factors right here, you are able to cancel them, but when you cancel them, they create a -1. Okay, so when I cross these out, I have to introduce a -1. You can put it upstairs, you can put it downstairs, it doesn't matter as long as you put it somewhere in the expression. So I could leave my answer as -1 and then 2 plus x over x plus 6. That's one way that I could write my answer. That's awesome. Or if you wanted to distribute the -1, you could. You don't need to, but you could. So you could write -2 minus x over x plus 6, right? Either way, that would be a correct answer. All right, now let's look at example number 2. We've got a multiplication problem here, but we need to factor first. Looks like we've got 4 positions here that we need to look at. If we start in our upper left-hand corner, I definitely see a GCF here. We can take out a 4x, and then we're going to be left with x minus 1. Right below that, we have an easy trinomial, two numbers that multiply to make -3 and add to make +2. That's going to be x plus 3 times x minus 1. Upper right-hand corner, we have another easy trinomial, two numbers that multiply to make -6 and add to make +1. That's going to be x plus 3 times x minus 2. And then we've got just that 4x monomial in the denominator. Monomials cannot be factored. Okay, so now we get to do some crossing out. So we're looking for what is the same upstairs and downstairs that we are able to cancel. Well, I know I can cross out these factors of x minus 1. I know I can cross out these factors of x plus 3. And I've got a 4x and I've got a 4x. So it looks like in my numerator, I have x minus 2. And I've crossed everything out in my denominator. So I could write it like that. Or if you prefer, you can just write x minus 2 as your answer. You don't have to put that over 1. Last example in this section is a division problem. Okay, when we are dividing, remember that we're going to do keep, switch, and flip, right? Factor first though. 5x is a monomial, so that's going to stay. This right here has a GCF of 3, so we take that out, and then we have a factor of x minus 4. I'm going to change my sign to times, and then I am going to flip this expression over. So the x squared minus 2x, again, that's just a GCF, but that's now going to go on the bottom. So I'm going to factor out an x, and then I'll have x minus 2. And then this is an easy trinomial on the top. Two numbers that multiply to make a +8 and add to make a -6. That's going to be x minus 4 times x minus 2. Now I get to do my reducing. What can I cross out here? I can cross out my x minus 2's, my x minus 4's, and this x here with this x here. Be careful, the 5 is still there. So my final answer is going to be 5 on top and 3 on the bottom. 5/3.